Today, the team at United Silicon Carbide, is now Qorvo, is pleased to introduce our new 4th generation 1200 volt silicon carbide FETs. This is a new expansion of our Gen 4 technology platform that delivers benchmark efficiency and cost effectiveness to designers building today's leading edge power solutions. The new devices are another great example of how we're charging ahead, delivering leading silicon carbide technology to our customers into high growth power markets. It's easy for one to find impressive growth rates that are forecasted for silicon carbide over the next decade. The latest study from Yole indicated a 34% compound annual growth rate from 2021 to 2027. If you dig into the Pareto of this growth, you can see that the automotive power market is the major driver of it. The primary applications in the automotive space adopting silicon carbide are the well-known traction inverter, but also the DC-DC converters that supply the increasing demand of auxiliary systems such as infotainment, etc. But outside the inverter and the DC-DC converters, the key driver for silicon carbide adoption in the automotive space is the onboard charger. And this is especially true with the move to the 800 volt bus. Today, we're pleased to announce the expansion of our 1200 volt product families to include the 6 new Gen 4 series FETs. These new FETs are well suited to address the needs of a growing automotive OBC and DC-DC converter markets, as well as a number of industrial applications. The new 1200 volt UF4 series parts are offered at 23, 30, 53, and 70 milliohms in industry standard 4-lead and 3-lead TO247 discrete packages. The new parts offer the industry's lowest RDS(on) times die area, along with all the additional benefits that the lower conduction loss per chip size affords. They have the industry's best figure of merits of RDS(on) times EOSS, a lower gate charge, and lower output capacitance. As with all the United Silicon Carbide FETs, they feature a simple 0 to 12 volt or 0 to 15 volt gate drive, and they're compatible with silicon MOSFET or silicon IGBT or even silicon carbide MOSFET gate drive voltages. They feature an excellent integral diode with a lower VF, typically between 1 and 1.5 volts, and have a low reverse recovery charge. These products also feature an advanced silver sinter die attach, which gives them superior thermal performance. The 53 milliohm and 70 milliohm FETs are offered in both 3-lead and 4-lead packages, while the higher current 23 and 30 milliohm FETs are offered in a TO247 4-lead, taking advantage of the Kelvin source connection to achieve clean gate waveforms. The Gen 4 products center around our new vertical trench JFET technology that's the closest to the unipolar limit of silicon carbide. We've introduced a new trench structure with reduced cell pitch and an optimized drift layer. To go along with these device cell improvements, we've also employed a further reduced substrate thickness to arrive at the industry's best specific on resistance. The new Gen 4 1200 volt FETs are nearly half the specific on resistance of competing technologies and are 40% lower than our previous generation. These performance improvements yield a lower output capacitance and lower stored energy in that output capacitance for a given on resistance. The impact on this technology improvement is evident here, where we show our previous generation 1200 volt FET with our new 30 milliohm UF4SC 120030K4S product. While the hot on resistance is comparable, the device offers a lower on resistance from room temperature up to 125 C. But despite the superior conduction losses, the Gen 4 device exhibits a lower switching loss, lower output capacitance, and lower EOSS. These performance advantages are beneficial to allow higher frequency operation and improve converter efficiency in both hard and soft switch circuits, as we'll see in later examples. In order to extract all the benefits of the improved RDS(on) times area, we've improved the thermal resistance, which maintains a good current rating despite the die shrink that affords the performance advantage we cited previously. By employing an advanced silver sinter die attach, along with further wafer thinning, we're able to improve the current rating by 30 to 48% and reduce the thermal resistance by 40 to 60% for a given die size. So despite a 47% size reduction from a selected competing device shown here, we're also able to offer a superior thermal resistance. In the example shown, the smaller die actually has a lower on resistance and a lower thermal resistance in the TU-247 package. This is further illustrated in the chart on the right, where here we're showing the thermal resistance of competing 1200 volt devices when normalized to our 30 milliohm 1200 volt Gen 4 series FET. The new Gen 4 1200 volt devices deliver the industry's leading figures of merit, as represented on this radar chart shown here. We normalized each of the parameters to that of the new Gen 4 silicon carbide FETs. And for each of the parameters plotted on the chart, smaller would represent better. As discussed on previous slides, the Gen 4 silicon carbide FETs offer a superior thermal resistance and a lower conduction loss for any given die size. But as one can also see here, they offer an excellent RDS on times COSS, both at room temperature and elevated temperature up to 125 C, which we represent here as a hard switching figure of merit. These devices are also great for soft switching. Their COSS time related is lower for a given RDS on than their peers. So this is excellent for high frequency soft switching. They also have the advantage of operating well with a lower gate drive voltage, so 0 to 12 volts. And when combined with the lower gate charge, this can reduce driver losses, especially in the high frequency soft switch converters, when compared to their 1200 volt alternatives. In this chart, we show the new 1200 volt Gen 4 FETs alongside their peers at room temperature and 125 C. Their lowest RDS on time COSS and low QRR of their integral diode make them attractive for hard switching. And also looking at the RDS on times COSS time related and low QG times RDS on, along with their lower VF of their integral diode and their very low conduction losses, make them nearly ideal for the soft switching applications, such as the primary side of isolated DC-DC converters. So now let's look at the new 1200 volt silicon carbide FETs in an example onboard charger with the 800 volt DC bus. We can use our online FETjet calculator to evaluate the performance of these new parts in a three-phase front-end rectifier at a power level of 11 kilowatts. In the example, we're assuming 230 volts AC to an 800 volt DC output, switching at 150 kilohertz and a heatsink temperature of 80 degrees C. There's just one FET per switch position for a total of 6 in the front end. The FETjet calculator can be found at our website at www.unitedsic.com, and it's preloaded with the new Gen 4 1200 volt FETs. Here you can see the excellent semiconductor efficiency of 98%, with a loss of approximately 37 watts per FET. And this is when switched at 150 kilohertz, allowing for improved power density. The anticipated temperature rise is a very manageable junction temperature of 115 degrees C. While our previous generation FETs perform well in this application, the new Gen 4 FETs can reduce the losses and improve the efficiency while running cooler and with a smaller die. The example illustrates how the new 1200 volt 23 and 30 milliohm FETs offer excellent cost performance options for the OBC active front end. We also mentioned that the new 1200 volt series was an excellent choice in soft switch topologies. As an example of this, we showed the same 11 kilowatt OBC, but now we look to the primary side of the full bridge CLLC. Here we're again at an 800 volt bus, soft switching at 200 kilohertz with an assumed heatsink temperature of 80 degrees C. We use one FET per switch position on the primary side of the bridge. Using the new 53 milliohm FET, or the UF4C120053K4S, we see an excellent semiconductor efficiency of 99.5% and a low junction temperature of 97 degrees C. Here, with a similar die size as our previous generation part, our Gen 4 part, with its lower conduction losses, reduces the losses by 20% and runs cooler. Both the new 53 milliohm and 70 milliohm 1200 volt FETs are great cost performance options for the isolated DC-DC converter stage. Beyond the automotive OBC, the new UF4C, UF4SC series 1200 volt FETs are great choices in many of the industrial applications that have been adopting wide bandgap. Some of these are battery chargers, power supplies, PV converters, welding, UPS, and induction heating. At United Silicon Carbide is now Qorvo. We're charging ahead with the introduction of 6 new Gen 4 1200 volt FETs, offering the industry's best performance. As we continue to deliver optimal silicon carbide power solutions for your high growth markets.